Morning and hello. How's it going, everybody? Today's March 25th, and we're going to talk about central angles and arc measure. Couple quick reminders before we get started. Please make sure you're signing up for CUDA Works. The links are on Google Classroom for all that, or shoot me an email if you're having any issues there, but please make sure we're getting that done. That's got the assignments for Tuesday and Wednesday. We'll be back on Delta for Thursday, and we'll probably be interchanging between CUDA and Delta Math a lot for the remainder of our time online. Also, a reminder that I've got Zoom office hours from 10 to 11 and from 2 to 3 every day, Monday through Friday. So if you have any issues, please come stop and see me. As always, details are posted on the classroom. So, a couple quick things I wanted to talk about with arc central angles and how to figure all this stuff out. I wanted to really quickly, this isn't actually part of your assignment, but I wanted to talk about how these things name in comparison to each other. So if I've got angle 3 here, we've got this guy. We can talk about angle 3 here. This corresponds to minor arc HI. Of course, it goes with a straight line there. But it corresponds to minor arc HI, so it goes just from here to here. So we call that HI. When we talk about major arcs, we got the vocab for this on Monday, and those are arcs that are greater than 108 or greater than 180 degrees. So I'm looking at the major arc for angle 3 being here. So the major arc, I have to do some comparison. I've got arc LK going here, but that's very clearly less than 180 degrees. It's less than half of a circle. So we're looking at that half circle as our 180 degrees. So I'd need the name going the other direction. So something like LMK. So my major arc, I could name this one a couple of different ways. I could talk about this as arc LMK or LNK. You could flip those names around, have arc KNL or arc KML. All four names mean the same arc. It talks about an arc that starts at L, goes through M or N, and ends at K. So when we name these, when you see those kind of figures drawn out like this, that's going to be an important fact for you to remember and keep in mind. Hopefully that should make, I think, a decent amount of sense. And if it doesn't name a major arc, we're generally talking about the minor arc. Minor arcs are a little bit more usable and more just generally what we get along with here. Remember that we can name angles with 3 letters and make sure you're paying attention on that. So the major arc for angle DQF. So I've got D down to Q and over to F here. Major arc is the more than 180. So I'm going the big direction. So I'll go from F through C and around to D. So I've got arc FC. D is what I'm talking about there. If you have any other questions beyond that, please see me during my office hours. Shoot me an email or just figure out a way to get a hold of me by any other means. I do want to spend a little bit of time talking about the arc and central angle measure. Now, when we talk about central angle, we talked about this a little bit on Monday, but that's an angle that's formed by 2 radii. So it comes out of a vertex. So I've got a central angle here. And what's kind of really nice and easy is our central angle and our arc measure will always be exactly the same. So if our corresponding minor arc here is 135 degrees, the central angle measure is also going to be 135 degrees. If I've got an arc measure here of 60, I've got a central angle measure of also 60 degrees. Nice, simple, no major complications there. And it really does. This is one of those, it's 2 different terms. They correspond directly to each other. That's not going to hold to be the case when we do some stuff next week. But central angles, arc measures, those guys always going to go directly together. All right. Measure of angle EGC. Now, if I look at EGC here, I should see that I've got an angle that doesn't quite have all the information filled in. I should have not a big deal here with a couple of bits of information that I should know. First off, going back to an old friend that we haven't talked about in a month or so, but still very much a valid part of everything, we have vertical angles. Remember these guys? When we've got an intersection going like this angle here is equal to that angle there. So you get in a bit of there's too much information, so we do a little bit of bouncing. I've got 127 as the measure of arc BF, so that's my measure of angle FGB is 127, and that's the measure of angle EGC, once again being 127, and that gives me what I need. So I can move in and along that vertical angle. Vertical angles still work here. You're also going to see those arcs correspond directly to it. NIJ, now here you get a little bit more, we're going to have those vertical angles come into play again, but slightly differently. One thing for emphasis is you do have a diameter here. What a diameter, you know a diameter of a straight line is 180 degrees. So we use that fact and our good friend vertical angles again, and vertical arc measures basically. So 63 degrees here goes straight into 63 degrees here, which goes straight into 63 degrees here. And if you're saying to yourself, but where's that work? Remember, we've got the 180 going along. So we've got our old supplemental thing going on where I've got 180 is my supplementary angles, and that equals angle NIJ plus angle NIM. We use vertical angles to show that this is 63 degrees here, and the question was angle NIJ. And I think we mostly can see where this is going. We're going to do our subtraction of 63, and we should get to 117 degrees for the measure of angle NIJ. Arcs are going to work with the same sort of math principles in them. So I'm looking for arc VX here. So we want to go make sure we label that really simply. VX, I'm talking about from here around to here. And yeah, don't overcomplicate this. It really is just addition 35 plus 55. So that's about that is a 90 degree arc going along here. The big thing on arc measure and central angles, don't lose your heads about them. One last fact to point out is that central angles and arc measures in a circle in general, they do add up to 360 total degrees. So UWT, I've got U through W and around to T. That's all of this. That's this big major arc going around the other direction. And there's not a whole lot of seemingly information there except for this 80 degrees and this 45, which is really a distractor. Because, as I know you guys know, a circle has 360 degrees. The minor arc we've got at 80 degrees, which leaves me at 360 minus 80, which gets me to run that straight on through 0, take it down to 2, you know, your standard kind of thing, 0, 8, 280 degrees for the remainder of the measure. So don't forget that 360 degree trick. You'd also have the 180 trick if you've got a semicircle, and vertical angles. Any sort of situation you get into, you're going to want to fall back and look at the fact that the circle is 360 degrees. A semicircle is 180, and vertical angles still apply. So I don't want to make this too much longer, please make sure you're checking this stuff out. Go through and work as many of these problems on CUDA Math or CUDA Works today as you can. And see me during my office hours if you have any questions. Thanks so much, guys. Have a great day.